Problem here, it says, in a recent study on world happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible life and 10 represents the best possible life. The responses were normally distributed with a mean of 4.7 and a standard deviation of 2.2. Answer the questions part A through D below. Okay, so let's see if we can't figure this out. Let me see. Give me 1 second here. Okay, just going to move that up a little bit. And let me do it again. I'm just going to have a lot of room here. Okay, so let's see. We know that our mean, mu, is 4.7, and our standard deviation is 2.2. So for part A, it's asking me find the probability that the person's response was less than 4. So we're looking for the probability that X is less than 4. Okay, so the first thing we're going to do, we're going to convert this to a z-score, okay? So the z formula looks like this. Z is equal to X minus mu divided by sigma. Okay, so what's my X number here? My X number is 4 minus mu, which is 4.7 divided by 2.2. Okay, so guys, I'm going to give you a heads up. When you're doing this problem on your calculator, the best thing to do is put this part in parentheses, okay? So let me get my calculator app here. Let me clear this out. And so we had 4 minus 4.7, close that off, divided by 2.2 equals, okay, now this is going to be my z-value. I'm going to round these to 2 decimal places. So to 2 decimal places, my z-value is going to be a negative 0.32. Okay, so this is saying what's the probability that z is less than negative 0.32. Now I think one of the most important parts, once I get to this step right here, is to kind of have an understanding of what does that mean. I'm going to draw my normal curve, okay? So here's 0. I know that negative 0.32 is going to be a little bit to the left. I kind of drew it probably a little bit too far to the left, but you kind of get what I'm getting at. So say that's negative 0.32, okay? We're looking for z is smaller than that. That means I'm looking for the area to the left, okay? So the area to the left. So the way I find the area to my left on my calculator, I'm going to use the normal CDF, okay? The normal CDF is going to have 2 values. The first one is going to be the lower value, and the second one, is going to be the upper value, okay? So what do I mean by the lower value? If I'm shading all the way over here to the left, the lowest value I have, that means this is going on forever and ever and ever and ever to the left. My lower value is going to be negative 9, 9, 9. I can put as many 9s as I want. And what's my upper value going to be? Well, we're stopping at a negative 0.32. Okay, there's a comma in the middle. So let me show you how to do this part on the calculator. So I'm going to go to my calculator, clear this out. I'm going to go second bars. I'm going to go to normal CDF. We said our lower value was a negative, a whole bunch of 9s, comma. Our upper value was a negative 0.32. Okay, so negative 0.32. And so the area that I'm coming up with is 0.37744 or 0.37448. And I want to say that they usually round to 4 decimal places. So let's see. My answer should have been negative 0.374. It's asking me to go to 4 decimal places. So I'd probably put 45 right there, okay? Let's see. All right. Now, let me go ahead and do part B. So part B says the participants is going to be between 4 and 6. Okay. So let's see. My mu is still, I want to say it was still 4.7, right? Yes. And my standard deviation is 2.2. So mu is 4.7. Standard deviation is 2.2. And we're looking for the probability that X is between 4 and 6. Okay. So x is between 4 and 6. Okay. So I'm going to do the same thing we did here. We're going to find our z value when x is 4. So 4 minus 4.7 divided by 2.2. Okay. So let me do this part of my calculator. Let's go 4 minus, oops, I forgot to do parentheses. 4 minus 4.7 divided by 2.2, oops, 2.2 is negative 0.32, okay? So negative 0.32, and then I'm going to do the same thing when x is 6. So 6 minus 4.7 divided by 2.2, okay? So let me take my calculator again, parentheses, 6 minus 4.7, close it off, divided by 2.2, and I'm coming up with 0.59. 0.59. Okay, so again, what does this mean? We're looking for when z is going to be between negative 0.32 and 0.59. So again, what does that mean in terms of my picture? Here's 0. So here's negative 0.32, and here's negative or positive 0.59. We're looking for the area in the middle. If I'm looking for the area in the middle, I'm going to use my normal CDF with my lower bound being, being a negative 0.32. There's not a point there. 0.32, and my upper bound being a 0.59. So let me do that part of my calculator. So let's come back over here. Let me clear this out. Second vars, normal CDF, a negative 0.32, comma, 0.59, and I'm coming up with 0.3479. So 0.3479. Okay, and I want to say there was a part C to it. Let's see. Part C says, find the probability that a random selected study participants was more than 8. Okay, more than 8. Okay, so we still know that our mu is 4.7, our sigma is still 2.2, and we're looking for the probability that x is more than 8. So again, just like we did before, we're going to convert this x value to a z-score. So x minus mu divided by sigma. So 8 minus 4.7 divided by 2.2. Make sure we do that in parentheses. Okay. So let me clear this out. 8 minus 4.7, close it off, divided by 2.2. 1.5 is my z value. Okay. 1.5. So now we're looking for the probability that z is greater than 1.5. Okay, just to get an idea again of what my picture looks like. Here is 1.5. We're looking for the area to the right. And you might say, why to the right? Because it needs to be greater than, which is that way to the right. Okay. So again, how am I going to do this? I'm going to use my normal CDF. My lower bound being 1.5, and my upper bound, because it goes forever and ever and ever, a whole bunch of 9s. Okay, so let me take my calculator again, clear it out. Second vars, normal CDF, 1.5, comma, and then a whole bunch of 9s, and I'm coming up with, to 4 decimal places, 0.0668. So 0.066